All right, so this is U7L1, the first lesson of Unit 7, and we're going to talk about piecewise functions. So our objective is going to be to graph, evaluate, and find domain and range for the piecewise functions. So the definition of a piecewise function is they are functions defined by different equations for different intervals of its domain. Right, so we basically split the graph into different intervals, and each of those intervals is going to have a different equation. Okay, so a couple examples here. We're going to graph the function first. So here is a piecewise function. It looks like this, right? It splits into like a big bracket here. Um, and then the bracket is going to give you the different equations. Okay, so you see here there are three different equations for three different intervals. So I have them color-coded. The orange one, you're going to graph in this orange interval. Yellow is going to be in the yellow interval, and red is going to be in the red interval. So the first thing I do is I split my graph. Basically, visually, I'm going to split the graph into different intervals based on the domain. Okay, these three parts here, the inequalities here, are the intervals, the domain that we're going to split them into. The first one is going to be x is less than -3, right? So in my graph, I look at -3 for x, right? Everything to the left of that, because x is less than -3. That's my orange interval, and that's where I'm going to graph the 2x. Okay. The next interval is the yellow one. For the middle one is going to go from -3 to +2. So that's the interval, that yellow interval right there. That's where I'm going to graph this yellow line. And then the red interval, of course, is going to be x is larger than 2. So it's going to be on the right side of 2. Okay, so I'm going to go ahead and graph this. I'm going to start with the first one, 2x. 2x is just going to be a straight line, right? However, I have to look at the domain, and the domain says x is less than -3, so it's in the orange interval only. You see the blinking part here. So the part that is outside of that, I have to get rid of it. Okay, so I erase that, and I have just this portion in the orange interval. Okay, and then it says x is less than or equal to -3, so I have to put a solid dot at the end there. That's my boundary, right? And then in the yellow interval, I'm going to graph the -x plus 5. -x plus 5 is, again, a line that goes down to the negative slope. Y and step is 5. That's fine. It's right there. However, I can only graph that in the yellow interval from -3 to 2. So -3 to 2 within this range right here. So then you see the blinking part? That's where I'm going to keep. That's in the yellow interval. So the other part I'm going to have to erase so they disappear, right? And then the boundary, look, it's greater than -3. There's no equal, so I have to have an open dot, right? Exclusive boundary. And over here, I have less than 2, also no equal, so I have to have another open dot over here. And then last one, I'll graph the line that says 3. All right, 3 is just a horizontal line where y is 3. And then I look at the interval here. It says x is greater than 2, so it's in this red zone, right? So anything outside I have to erase and get rid of. There it is. And here you see that this open dot. That is from the yellow part. But this one has an equal sign, so right there I had to put a solid dot, so it covers that up. So that's my graph now, okay? All right, so the next part is we're going to evaluate this. So when they say f of 5, what is that equal to? F of 5 meaning x is 5, what is y? So I look for when x is 5, and it's in this red zone, right? Because 5 is in that red zone. So this one way, there are two ways to do it. One way is to look at the graph. When x is 5, I look up where's the graph. It's right here, right? So that is when, y is 3. There's another way to do it. You look at where it says x is 5. Which one is x 5? This one is less than -3, so that's not 5. 5 is not between -3 and 2. 5 is larger than 2. So I look at the red one, and the red one says f of x is equal to 3. So I have f of x is equal to 3, or f of 5 is equal to 3. Okay, so Again, two ways. You can do it by looking at the graph or looking at the equations. When you look at the equation, you have to pick out which one it is, right, based on what x is. For instance, this next one, f of 0. Okay, again, you can look at the graph. When x is 0, you go up here. Oh, y is 5. Okay, that's easy. If you don't have the graph and you look at the equation, where is 0 going to be? Is 0 less than -3? No. Is 0 between -3 and 2? Yes. So I can look at the yellow one, right? And I use this equation, the yellow equation. So f of 0 is going to be -0 goes in for x plus 5, which gives you 5, which corresponds to the graph. Okay. The other part of evaluating is when they tell you f of x is equal to a value, and they ask you to find x. Basically, this says y is equal to -10. What is x, right? So this one, the best way is to look at the graph. It's hard to do it without the graph. Okay, so when y is -10, so I look at -10 for y, right? There's -10. Then I'm going to go across until I touch my graph right there. So that's the point that we're looking for, right? That's the point where y is -10, and you look for x. Well, x is going to be -5, right? So the graph tells you x is -5. We can do one more. F of x is 3. Basically, y is 3. What is x? So I go up to when y is 3, right? Right here, y is 3. And then it touches at so many different points. So basically, x is anything from the right side. Start touching at 2 and anything on the right side. So x is larger than or equal to 2. All right? And then we do the domain and range. Let's do the domain, okay? Domain, you count your x values. Which x values are on the graph? So from left to right, this one covers everything. And here, look, this one is open dot, so there's no x value here. However, it's covered by this one. So all the x values are covered. You get all real numbers. And then the range, I look at the y. So from here down, there's y values, right? So y is less than, -6, not 6. And then up here, I have y between 3 and 8. So y is right here is covered, so y is larger than or equal to 3, but here it's not covered, so it's less than 8. We'll do another example here. Okay, so we're going to graph these. Again, I split them into 3 sections. The orange one less than -5, the yellow one between -5 and 1, and the red one on the right side of 1, right, greater than or equal to 1. And then I graph 2. There's that line. However, I can take it in the orange part only, less than -5. So there it is. I erase the other part and I put an open dot because there's no equal. The second part I graph is -1. So there's -1, just a line across. However, it's only in the yellow interval. So between -5 and 1. There it is. I erase the other part and I put a solid dot on -5, right? And open dot on 1. Solid dot, open dot. And then next one is 2x plus 5. There's 2x plus 5, but it's in the red zone only. So I get rid of the other part and I put a solid dot for the equal sign. And then evaluating f of -5. Okay, where is -5? Right here. What is y? Well, it's not up here, right? It's got to be down here. So I get -1 because up here is an open dot. If you have 2 values, then it's not a function anymore. Okay, it doesn't pass the vertical line test, right? This one is only 1, so it's still a function, and the value is at -1. F of 3. Oh, by the way, if you do it with the equation, -5 is not the orange one, right? Because there's no equal sign. So you see, there's a hole there. X is -5 is not less than -5. It's equal to -5. So you have to use the yellow one. So it's at -1. Again, corresponds to the graph. And then F3, you put 3 in. For x, which one should you use? Is it less than -5? No. Is it between -5 and 1? No. Is it larger than 1? Yes, 3 is larger than 1. So you use this equation, which corresponds to the red graph. And then you put 3 in for x. 2 times 3 plus 5 gives you 11. F of -10. -10 is over here, right? So it should be at 2. Which -10 is less than 5, which gives you 2. So either way you do it is fine. If you don't have the graph, you have to look at the equations. And then f of -10, what is x? You go to -10 for y. Right? Look for x. Where is it touching the graph? Nowhere. So it does not exist. Okay. How about f of 9? What is x? So you go up to 9 and touch the graph right there, which x is going to be 2. Right here, 2. And the domain, again, every x value seems to be covered, right? So all real numbers. The range is going to be the y values just here. There's nothing down here, right? So it's just here, y is at -1. And then here, y is at 2. And here, y is larger than or equal to 7. Now, one last thing we're going to do is we're going to write the equation from the graph, right? So here's the graph. We're going to write the equation. So there are 3 pieces. Now, my function is going to have 3 lines, right? 3 equations. First one, I'm going to do the red one. Okay, it looks like just a line across 1.5, right? So your equation is going to be 1.5. And then I'm going to do the domain. It looks like it's on the left of -2. So x is anything less than or equal to -2 because the solid dots are equal. So anything is, x is less than or equal to -2. Then I go to the next one. The equation looks like it's like 1/2 x because the slope is 1/2. So it's just 1/2 x. And then the domain is between -2 and 1. Right there. Okay, open dot means no equal sign. Closed dot means equal sign. The last one looks like the slope is -1. And if I go up here, I'm going to have to kind of project because I don't know exactly where it's going to be. It looks like it's going to intersect at 0.5. Um, I got the wrong number there, but you know what I mean. It should be 0.5, -x plus 0.5. Basically, the equation for the graph, for the line. And then I set the um, interval. It's on the right side of 1, so x is larger than 1. Remember, open dot, no equal sign.